In the previous videos, we learned how to solve systems of equations using a graphing method. Remember that the solution to a system of equations is written as an ordered pair, wherever your two equations are equal. So we always write our value as an ordered pair, and it's telling you where, if you were to graph these equations, they would cross each other. We can also solve systems of equations using algebra without having to graph them, and I'm going to teach you that today. So we can solve systems of equations by eliminating a variable. Variables will eliminate when their opposites form a zero pair. If a variable doesn't eliminate on its own, you have to use multiplication to create your own zero pair. So I'm going to do some examples of this to show you what I mean by creating a zero pair and using multiplication to create your own zero pair. This elimination method is also called, so I'm going to put AKA, addition method, because we are going to be adding these two equations straight up and down. So if I'm looking at example number 1, I have to see if this has a zero pair. So I'm looking at the same variable. I'm looking at the terms that have the same variable. So negative 3x plus 6x would not be a zero pair. 5y and negative 3y would not be a zero pair. But if I multiply this top equation by 2, 2 times negative 3x would give me negative 6x, which would cancel out this positive 6x. So I'm going to multiply everything by 2 to get negative 6x plus 10y equals 48. So all I did is I multiplied everything by 2. And I rewrote that down here under my original equation. So now I'm going to add straight down. 6x plus negative 6x cancels out. Negative 3y plus 10y is 7y. Drop my equal sign. 15 plus 48 is 63. Now I need to get y by itself, so I'm going to divide both sides by 7. I get y equals 9. So I know my answer has to be written as an ordered pair, and if y equals 9, I have to plug it back in and solve for x. So I'm going to use this second equation. So we have 6x minus 3y equals 15. And at this point, it doesn't matter which equation you pick. You could have picked the top equation, you could have picked the bottom equation, but I'm going to plug 9 in to solve for x. So I have 6x minus 3 times 9 equals 15. All I did is I plugged this y value in everywhere I have a y in my equation. So I get 6x minus 27 equals 15. I'm going to add 27 because I have a minus 27. The opposite of minus 27 is plus 27 to both sides. That cancels out. I get 6x equals 15 plus 27 is 42. Divide both sides by 6. I get x equals 7. So I'll put 7 in the x spot. Good. Let's do another example. We have this example here. 3x minus 10y. Oh, that's a you try. Let's do this one down here since they want you to try that one on your own. But I'll do this one with you here. We have 6x plus 12y equals negative 12. And 3x plus 5y equals negative 3. 6x and 3x don't cancel out. 12y and 5y don't cancel out. So I need to figure out what I can multiply one of these equations by to get a zero pair. I know that 6 is a multiple of 3, it is multiplied by 2. So if I multiply this bottom equation by negative 2, then I'm going to get a negative 6x to cancel out that positive 6x. The only way they cancel out is if they have opposite signs. So when I multiply that by negative 2, I get negative 6x minus 10y equals positive 6. I'm going to drop down my original equation because I did not do anything to it. So plus 12y equals negative 12. And I'm going to add these together. 6x and negative 6x cancel out. Negative 10y and positive 12y is 2y equals 6 plus negative 12, which is negative 6. Need to get y by itself, so I'm going to divide both sides by 2. Y equals negative 3. So I plug in negative 3 for y, and now I have to figure out what x equals. I'm going to take my top equation. I have 6x plus 12y equals negative 12. And everywhere I have a y, I'm going to put this negative 3. So I have 6x plus 12 times negative 3 equals negative 12. 6x minus 36 equals negative 12. I'm going to add 36 to both sides. 6x equals 24. Divide by 6. X equals 4. So if I were to graph both of these equations, they would cross at the point for negative 3. Go ahead and try numbers 1 and 2. You are going to have to multiply both of these equations. I'll give you a clue for this first one. You're going to multiply the whole thing by 4. I'm not going to tell you which variable that'll cancel out, but when you multiply these by 4 and add it to this bottom equation, one of your variables will cancel out. And you should try to figure out what you need to multiply this equation by, and you're going to multiply the bottom equation. So you're going to multiply that bottom equation by a constant in order to cancel out some of your variables. Go ahead and pause the video and finish those two examples. I will do example 3 with you also, so hopefully you have finished those two examples on your own, so by now it's a little bit easier for you. For example 3, we have negative 4x minus 2y equals negative 12, and 4x plus 8y equals negative 24. And as you can see, negative 4x and 4x are a zero pair, so you don't have to multiply those by anything because those automatically cancel each other out. So I'm just going to add straight down for this one. Negative 2y plus 8y is 6y. Negative 12 plus negative 24 is negative 36. When you divide both sides by 6, you get y equals negative 6. So now I'm going to plug this into one of my equations. I'm going to choose that bottom one. We have 4x plus 8 times negative 6 equals negative 24. 8 times negative 6 is negative 48, so I'm going to drop everything else down. I'm going to add 48 to both sides using the property of addition. I get 4x equals positive 24. Divide by 4, x equals 6. So I have x equals 6, y equals negative 6. I would write that as the ordered pair, 6, negative 6. Again, pause the video, try number 4 on your own. You are going to have to multiply one of these equations, and it looks like you have two options. So you can multiply it two different ways and get the same answer. For this one, for these 6 bottom questions, they don't want you to solve it. They just want you to figure out how you're going to solve it by using multiplication. So if I'm looking at this problem right here, I have 3x plus 4y equals 12 and 2x minus 2y equals 10. I need to get one of these to cancel out. 2 and 3, their multiple is 6, so I'd have to multiply both of these equations. 4 and 2, both of them have a multiple of 4. So if I multiply this bottom equation by 2, it becomes 4x minus 4y equals 20. And this top one would stay the same. 3x plus 4y equals 12. So in order to solve this system using elimination, I multiplied the bottom by 2, which is how I got this. From here, I could solve it, but they don't want me to do that. All they're asking us to do is figure out what we need to multiply our equations by. I'll do one more with you, and then you can do the remaining 4 on your own. I have x plus 5y equals 2, x minus 7y equals 3. Remember that if you don't have a coefficient, you have an invisible coefficient of 1. Whenever you have a coefficient of 1, it's really easy to multiply that variable because the bottom equation or the other equation tells you what to multiply by. So to cancel out this 8x, I could multiply this whole top equation by negative 8. So negative 8 times 1x is negative 8x. Negative 8 times 5y is negative 40y. Negative 8 times 2 is negative 16. I would leave this bottom equation the same, and these variables would cancel out. So for this one, I'd multiply the top equation by negative 8. Alright, go ahead and do these practice problems, and I will see you in the next video talking about using systems of equations to solve word problems.